Aha. Okay, so I'm going to do a little talk about storage. And I'm not going to plug your product or some shit. I don't believe in that, so we're not going to do that. We're going to tell you my live experience with storage in larger infrastructures. So at Schuberg, we have quite a large infrastructure, a pretty big cloud. It's on over 3 zones and quite a bunch of hypervisors and nice scale. We started out small, as everybody does. I'm going to skip the slide introducing me because we've already had that. And I'm going to tell you about our ventures into storage and what that meant for us, and kind of the problems we found, and people screaming at us and kind of burning us, and all of the nasty bits that you'll run into once you start doing scale and your customer screaming at you, and it's really the fun bits, kind of. So we're going to go down that path, and I think an important thing to kind of know is that when Schuberg started building our cloud 6 years ago, when we started doing this, we built it to be able to absorb traditional workloads, so like your Oracle database and all the monolithic crap around that, but also be able to venture into la-la land to web scale. So you need to have storage that actually performs or can kind of hold on to those boundaries, but also be able to use to scale out over those edges and basically build a decent fabric. So the thing with storage is actually that it's quite interesting. You've got 3 choices to make if you want to do it within certain bounds. If you look at traditional storage, the options you get is you either have really fast storage, you have really reliable storage, or you get you get really cheap storage. Those are the 3 options you have. There's nothing in the middle. If you want all 3 of them, you're going to pay through the nose, period. Just deal with it. It's going to cost you an arm and a leg, and that's what you do. So we went for the pay through the nose option. As one does. We went for a triple mirroring on the ZFS for our primary storage, and we basically just said, well, we're going to do a cluster per 2 pods because that makes sense. IO-wise, we can do 100K IOPS, so that should be okay. Not really a worry there. And for secondary storage, we did RAID Z2. So that was the initial design we did. Before that, we were actually experimenting with ZFS with Equalogics as a backend, which is we got them on the scrapyard. We started playing around with it. You kind of get a feel for the semantics. You get an idea of how performant it is and how well the Arc actually works and how well those components work, and you get a real good feel for it. So we actually used the squeaky wheel syndrome there, that if shit would go wrong, the engineers would be playing around on that infrastructure, and they would literally call us like, oh, my VM's not working, or I'm having performance problems, and we'd look at it and play around with it and fix it, or say, well, okay, so in our first design, we need to change these things to accommodate those kind of workloads. So our first design was a beta design where we actually worked with a commercial ZFS provider that gives support, which is great because people are kind of hooked on support. If you come from an enterprise background, if it doesn't have support, you're not going to do it, which is kind of horrible in a way. But that was the way the world was. So I went with these guys, and we found some problems, and we fixed some problems, which is great. That's something we'll get back on later. I think the first thing is that if we look at clouds and what people call clouds, is that the first order usually is that people take VMware, put some scripting around it, and then call it cloud. It's like my first Sony of clouds, Cloud Zero I usually call it, because it's not really a cloud. It's actually trying to use lube with a Rhino. It's not funny. It's not great. You don't want to do it. Because oh shit, I'm going too fast. Actually, so it's not great. So actually, if you look at that model, what you usually see is people have a very centralized architecture. And the first order step that they take after that, which is Cloud 1.0, is a decentralized approach, where they say, well, I'm used to this architecture. Now I'm going to move it a bit further. So I'm going to do top of rack. I'm going to put some stuff in a pod. I'm going to do some storage in the bottom. And that's my Cloud 1.0. So I'm going to segregate stuff, usually in a single layer 2 domain over multiple zones, or multiple, what do you call it? Data centers, those things. And basically create a flat layer 2. That's usually the Cloud 1.0 that people poop out, which is actually a decentralized model with very centralized characteristics. Once you've done that and shot yourself in the foot a couple of times with the layer 2 connectivity, you'll get to the point where you say, well, maybe we should do layer 3 at the top of rack. So then you get to the notion of you leave spine construction, I do layer 3 at the top of rack, I still have my storage underneath, and I have my compute on top. And usually that's a balancing act. You do a wet finger, you know, like it's like looking where the wind's coming from, so you kind of do math on it, and you go like, well, we're using this much storage, on this much memory, on this much CPU. Let's do that. So we actually went for 90 VMs per hypervisor, and we said 256 gigs of RAM per hypervisor, and then 16 cores per hypervisor, and 24 hypervisors per rack, and then basically slot in the bottom, slot your storage. Very simple. Worked really well for the traditional workloads. Great. So we're well on our way, you know, everything's going well. We're doing our first production, you know, we're happily married, first production, yay, fucking awesome. Sitting there, you know, proud of ourselves. 2 months too early, we thought, but you know, you need to bite the bullet at some point. And after like a month, everything came crashing down. It was really awesome. So we had pods fail. And when pods fail, customers are not happy because they're running mission critical workloads. Schubert guarantees this 100% uptime thing, which is kind of a big deal for them. I don't know why, but it's a big deal, you know? You guarantee your customer 100% SLA and then they start whining if it doesn't work. You know, come on, really? So anyway, so we had pods crashing down. And we're sitting there like, whoa, what the heck happened here, you know? It's not very good. I mean, it's like, you know, you built your house from straw. And that was kind of painful. So we're sitting there going like, you know, oh, crap, what's going wrong? And we found out there was a bug in the firmware of the disks, and it turned out that ZFS actually can't evict drives loose from the file system. And so you go deeper into the rabbit hole, deeper into the weeds, and you start filing bugs with the supplier you're working with. You know, it's literally like the fucking roof is on fire, and everything is collapsing around you, literally. So we literally had every week a pod would go down, a random pod. The fallout was humongous. We literally had corrupt file systems on VMs of customers, and customers are actually like banks, you know, that kind of stuff. Not cool shit. Luckily, we built everything redundant, so the other leg would be okay. But you know, it was just waiting for it to happen that both legs, so both pods would go down at the same time. And it's like, that's not something you want to get into. You know, it's not fun, it's not great. So we're sitting there pulling our hair out, getting gray hairs, losing sleep, like what you gonna do? You know, what are the options you have? So you go to the next step and you build your house from wood. So you go back to the vendor you were used to, you know, did a lot of business with, a large NFS supplier, and you start working with them, and they're like, oh, we're going to give it to you cheap because we want you to get rid of the other crap. And you don't tell them it's completely crap, of course, so you get a good deal. That's the way it works. You know, that's how shit works. And getting a deal, but in the meantime, you're building your house from wood, and you're not aware of this yet. You'll find out later. You know, it's like you're building a house from wood, you're like, yeah, we're back on track. We're building a house from wood. Yeah, it's really awesome. Until you kind of find out that you're building a unicorn that's not really a unicorn. Because you start to figure out that you're still building monolithic storage on a scale-out infrastructure. Wait, that is actually really fucking stupid. So you've got your pod design with your 3 or 4 shelves in the bottom, your clustered head on top of it. You've got your compute, really awesome. I've got my redundant switches at the top, but I ran out of disk space. What the fuck am I going to do now? Shit. And there's people that want to do mirroring of shit. Yeah, I can't do that with this crap. So I'm going to bridge in storage. That's a really good idea. So our burning duct tape was to build bridge in storage. So we actually did a lot of stuff with SDN. So we actually had gateways on the edge, and we'd bridge in external VLANs into virtual space, and in that way we could actually import iSCSI UNFS into the logical space of the client. Seemed like a really good idea at the time. Really, seriously, we had no other option. It seemed like a really awesome idea. But you know, you're basically sticking the plumber on the donkey, and you're going like, oh, it's a unicorn, it's cloud, it's awesome, really cool shit. That turned out to be a bit of a failure. So you start looking for alternatives, and what are the alternatives you have? There are actually very few alternatives. If you want performance storage scale out, you're kind of screwed. I mean, we all know Ceph that exists. You know, performance is kind of a problem. Managing it is kind of a problem at scale. If you do a small set, it's nice, but as soon as it grows, you know, you traverse a couple of racks, and as soon as it goes traversing across those couple of racks, you notice that the guys that are actually managing the system are growing with the racks. It's really funny. So I start off with like 3 engineers, and I've got like 5 racks, and then when I hit 8 racks, wait, I've got 8 engineers. What happened here? That are managing Ceph. It's really weird. It's just strange. So And in that way, I think the whole golden situation is if you can get to a point where you can actually have scale out infrastructure that actually works and is manageable, is lights out, and gives you the advantage to kind of go to the point where you say, well, I can actually grow my storage separate from my compute. Because most people are pod-centric because they're afraid of failure domains, but they forget that if you're doing it pod-centric, you're also painting yourself in the corner storage-wise. So what we did at SuperX is we said, well, our first iteration was to slant the entire pod model and say, well, a pod is actually a neighborhood. And a neighborhood can consist of a bunch of storage and a bunch of compute and some networking components. But you slant the model. The downside is you get a lot of east-west traffic when you do that. Is that a problem? It depends on your networking backbone. How big is it? Are you doing 40 gig at the top? Are you doing 100 gig at the top? Does that work for you? Doesn't it work? So those are some problems you encounter then. So if you look at it really, really, really seriously, you'll get into the point where you say, well, actually I want distributed storage at the bottom of my racks, but I want locality, because locality is important. I want my storage to live very close to where my compute lives. Because if I don't do that, I get all the east-west traffic for it. Now the other thing is, let's be honest, I think nobody on 8 racks is doing 100 gigabit on storage traffic. I don't think anybody is doing that. So should you worry, shouldn't you worry? It's all one of those exercises you need to get into and see what your workloads are like. And that's, it's kind of the point I made earlier. It's all workload centric. Everything you do is catering for the workload you actually ingest. And if you don't know the workload, you need to be able to cap stuff at the right points, or else, you're kind of screwed because you're not able to guarantee anything on your fabric or on the experience that people will have, which is really the issue. So if you look at the data placement is important, quality of service is important, knowing your workloads is important, but also if you have workloads that you know nothing about, you're going to find yourself in the position that you need to collect metrics on those workloads, on those hypervisors. How are they being used? How is utilization? How is utilization on my storage backbone? How is utilization on my network backbone? How is utilization on all these segments? So we actually built a platform where we said, well, we're going to ingest all our metrics, and some people do it with OpenTSDB, like Pierre-Luc does. Some people say, well, I'm going to use InfluxDB or some other stuff, and basically ingest all those metrics and do calculation. I'm looking at how your system is performing, and being able to trigger events off those things and say, well, we're out of parameter on either networking or on storage, and being able to correct, from an operational perspective, the experience for your user. Because that's the most important thing eventually. So in a way, you hope to achieve the stone house effect there. So you're not anymore in your fucking straw shit shack. You're not in your wooden shack anymore. You've got this nice stone house. It's nice, cozy, and warm, and the wolf can't blow it over, you hope. But to be honest, you'll always run into operational problems, always. And then the real issue becomes tooling around your operations. And I think that the real issue is that once you start doing things at scale, at larger scale, you'll find that operational excellence and having the tooling around it is the thing that will actually bring you the benefit. So even if you're still stuck in the first phase where you still have a straw house and you think you're building a cloud while you've only got one rack with monolithic storage plugged in the bottom, the tooling around it is still very important. And I can't stress it enough. And making that tooling scale iteratively is very important too. Which actually brings me to the last point, is that I think nobody wants to lose data. Nobody wants to be in the business of losing data. So it's very important to keep your data safe. So think about it when you're designing your storage infrastructure underneath your cloud. It's not the same as I'm building a small customer or I'm building a single customer. You're actually building a fabric that is larger and more complex from an operational standpoint than a single customer will ever be. That's my 2 cents. Any questions? This is easy.
You have a question over here? Question? Somebody over here have a question?
No. Wow, that's great. I did a really bad job.
We do have a question from the live stream.
Oh, okay. Oh, fuck. No. God damn it. Well, I think there's another point I'd like to make, and there's one thing that is really interesting when we were at Schubert and we did the ZFS to NetApp transition, because it was NetApp we went with then, is that you have to do a forklift replacement of what you have in place, which is not a very fun thing to do. Remy did all of that work back then. The tooling he did around it actually is all on GitHub. So he actually wrote a lot of tooling that allows you to move VMs around without impacting what's going on underneath. Because we noticed that the live storage migration in CloudStack was actually horribly broken. You know, and that's also a thing to keep in mind. Live storage migrations are not fun, so design it well and make sure you have iterations and you can grow through it instead of having to do a forklift replacement of something. Because when you do a forklift replacement, it always means downtime. Always. You're just, you know, you're just going to have to bite the bullet and it's going to happen. Anyways, my 2 cents.